A particle moves along the x-axis so that at time t, its position is given by x of t equals t cubed minus 6t squared plus 9t plus 11, where t is measured in seconds and x is measured in feet. All right, so you have this guy moving along the x-axis, okay? Now, this is its position. This is where it is on the x-axis left to right, which means looking at this problem, we were talking about velocity. We're talking about maybe acceleration, but let's at least, I see the word velocity. Let's try to understand what velocity means in this context, because I see that phrase right there. Okay, the derivative is velocity. Now, a negative velocity is real. I mean, I know in the real world, if I were to, drive backwards 10 miles an hour, I wouldn't say that, oh, I'm going negative 10 miles an hour, but that's actually what we're doing. All right, so here, a negative velocity would mean going left. So if this is negative, that would mean we're going left. If this is positive, that would mean we're going right. So what I want to do with this first guy is at t equals 0, is the particle moving right or left? I need to take the derivative, okay, and see where I'm at when t equals 0. So that's going to be x prime of t equals, power rule a bunch of times, 3t squared minus 12t plus 9. Okay, this is very simple because I'm plugging in 0. So x prime of 0 is going to be 0 minus 0 plus 9, right? And that's going to be a positive 9. So a positive 9 means at this moment I am going positive 9 feet per second. So since it's positive, that indicates that I'm going right. So I'm going right because I have a positive velocity at t equals 0. So that's me explaining without having to explain too much because I don't feel like it. At t equals 1 is the velocity of the particle increasing or decreasing. Now this is very, very, very similar to what we just did, because if I were to take the derivative again, that would give us acceleration. Now acceleration is you speeding up or slowing down. Okay, so if I were to, at a specific point, and at this point 1, if I were to get something that's negative, that means at the moment I'm slowing down. Okay, if I were to get something positive, that means I'm speeding up at that moment, right? I know those words aren't being used here. And this is asking if the velocity is increasing or decreasing. That's the same thing. If I'm driving, right, and my miles per hour goes from 10 to 12 to 14, that's me accelerating. So this is the same idea. So what I need to do is I need to take the derivative of u, so it's going to be power rule again a couple times, and then plug in 1 and see what happens. So if I take the derivative of x prime of t, that gets me the second derivative. Power rule is going to give me 3t squared becomes 6 regular t, minus 12t becomes minus 12, and then plus 9 disappears. I care about what happens at t equals 1. So x double prime of 1 is going to be 6 times 1 minus 12, which is 6 minus 12, which is negative 6. So that negative 6 indicates that I'm slowing down. So my velocity is decreasing because I have a negative acceleration. Okay? And that would be why. So what else? Find all values of t for the particle that's moving left. All right, so again, this goes back to the moving left problem. This goes back to problem A. So problem A, what I have is I care about when it's moving left, and that's going to involve me finding out all the intervals where I have a negative velocity. So let's take this guy. Okay, now when you have a particle moving left or right, you care about the negative velocity, which means we care about when velocity changes. So what I have to do is find out when the velocity is completely 0, and that'll indicate where my velocity changes. So what I do is I set u equal to 0, And I'm going to factor that equation out. First thing I can do is I can pull out a 3. That's going to make life easier. T squared minus 4t plus 3. And that's going to allow me to factor out to 0 equals 3, t minus 1, t minus 3, which means my magic numbers are going to be 1 and 3. 1 and 3 are my critical points, which means 1 and 3 is where the velocity is 0. That means I'm stopped at that moment. So I'm expecting this guy to move from like right to left to right. But how do I know that? Well, let's make ourselves a sine table for x prime of t, right, of t, and my zeros are 1 and 3. I know it's moving left if at any moment I plug in a number into the derivative and get a negative number. I know it's moving right if I plug in any point into the derivative and get a positive number. So what I'm going to do is I'm going to pick negative, 100, and in my mind plug it in. Actually, you know what? No. I already did that. I'm just going to plug in 0 because I wasn't thinking there. So I'm going to plug in 0. I'll plug in 2, and I'll plug in positive 100 to see what I get. I know from part A that when I plug in 0 into the derivative, I got a positive velocity. So you are positive up here. So you're not moving left, you're moving right. If I plug in 2 into the derivative, I would get 3 times 4, which is 12, minus 24 plus 9, which is a negative number. If I were to plug in 100, I would get 3 times like a really huge number minus like 1200 plus 9. That's going to stay positive. Okay, so that's my sine table. According to my sine table, I am negative between 1 and 3, which means I'm moving left between 1 and 3. So the values of t, where this particle is moving left, is going to be t is in between 1 and 3. Including 1 and 3? No, because at 1, you're stopped. And at 3, you're stopped. So this is me writing it out in inequality notation. You could use the parentheses 1 comma parentheses 3. Whatever works. In between 1 second and 3 seconds is when we are, seconds, right? Yes, seconds is when we are moving to the left. Okay, so that is C. Last but not least, we got displacement. Displacement is where you are now at the moment, not how your distance traveled. Where are you, according to Blink-182? Get it? Miss You? It's a lyric in Miss You. I also said to the left. It made me think of Cupid Shuffle, but I didn't sing that. How do I find displacement? Well, my original position function is x of t. So my displacement is found by taking where you are now, 6 seconds, and subtracting where you were at the beginning. So I need to find x of 6, and I need to find x of 0. So x of 6 is going to be 6 cubed minus 6 times 6 squared plus 9 times 6 plus 11. This is actually super convenient because 6 cubed minus 6 times 6 squared is also 6 cubed, so you completely go away. And you become 54 plus 11, which is 65. X of 0 is going to be 0, 0, 0, 0, 0, 0, 11. So my displacement is going to be, I'm now at 65 feet to the right. I'm subtracting 11 feet to the right, which means I went from 11 to 55, and that is a change of, why am I struggling, 54 feet? So there you have it, 54 feet. So very involved problem, but we covered a lot of things here in this problem. I enjoyed it. It was fun.